Hello and welcome to the third class of the polynomial chapter, and today we will discuss about the polynomial division and the remainder theorem. Let's enjoy today's class. From our childhood, we know a formula that dividend equal to divisor into quotient plus remainder. For example, when we divide 8 by 3, then we have quotient 0, remainder 2, the divisor is 3, and dividend equal to 8, that means 8 equal to 3 into 2 plus 2. In this way the formula is satisfied. Now let us expand this concept into the polynomials. Divide 3x square plus x plus 1 by x plus 1. Here x plus 1 is the divisor, this is the dividend, and this is the quotient. We divide in the usual way and get the remainder 1 here also 3x square plus x minus 1 equal to x plus 1 into 3x minus 2 plus 1. That means this formula is satisfied. Now in this example, as I have already told, that dividend polynomial is px equal to 3x square plus x minus 1, divisor polynomial equal to x plus 1, quotient polynomial equal hx equal to 3x minus 2, quotient polynomial 3x minus 2, and remainder polynomial equal to 1. Then px equal to qx into hx, px equal to dividend polynomial equal to divisor polynomial into quotient polynomial plus remainder polynomial. Since the divisor polynomial qx is a linear polynomial, qx is a linear polynomial, then it must contain a 0. Since linear polynomial, from our property in the last class we learned that it must contain a 0, then let x equal to c be the 0 of the polynomial qx. That means qc equal to 0. Since c is the 0 of the polynomial, that means qc equal to 0. That means from this formula we have px equal to qx into hx plus rx. This is satisfied for all x. For all x this is satisfied. That means if we substitute x by c, that means pc equal to qc into hc plus rc, but qc equal to 0. That means pc equal to 0 into hc plus rc. Since qc equal to 0, that means pc equal to rc. So we get the remainder directly by this formula. We need not to calculate remainder in this way. We can directly find out the remainder by this formula. How we can find it? Let we know by some examples. For verification, let us take the previous example where the dividend polynomial px equal to 3x square plus x minus 1, divisor polynomial equal to qx plus 1. Let x equal to c be the 0 of the polynomial qx, that means the divisor polynomial qx. Then qc equal to 0. That means we have to substitute c by x, qx equal to x plus 1. We have to substitute c by x, that means c plus 1 equal to 0, that means c equal to minus 1. Now for remainder we have to calculate pc. That means p of minus 1, that means 3 into minus 1 and whole square, minus 1, that means 3 into minus 1 whole square means 1, then 3 into 1 minus 1, so 1, then the remainder is 1. Here also we find that remainder is 1, and in very easy way we have to calculate remainder by method. It will take so much time, but in this method we can find the remainder in very short time. Now we will learn the remainder theorem. The remainder theorem. The statement is, let Px be the polynomial of degree greater than or equal to 1. We know what is degree, and let Px be the polynomial of degree greater than or equal to 1. Let a be any real number. Let a be any real number. Real number means anything we know. That means 1, 2, 0.1, 0.2, 0.5, 5.2, 7.2, minus 5.2, minus 7.2, minus 10, minus 100, minus 700. Anything we know that is real number. Let a be the real number if Px is divided by the linear polynomial x equal to a, then the remainder is Pa. If Px be divided by x minus a, that means x minus a is the divisor polynomial and Px is the dividend polynomial, then the remainder is Pa. As we find in this example, Px, the remainder becomes Pc since since c is the 0 of this polynomial, and if x minus a is the divisor polynomial, then x minus if x minus a is the divisor polynomial, then the 0 of the divisor polynomial is a, that means the remainder is Pa. Since qx equal to, here qx, the divisor polynomial is qx equal to x minus a, since we are dividing by x minus a, that means x minus a equal to 0, that means x minus a equal to 0, that means x equal to a, that means the remainder is Pa. Since the 0 of the divisor polynomial is a, that means the remainder of the remainder is Pa. We have done the proof in the previous page. Now let us take the last example of today's class. Find the remainder when x cube when x cube plus 3x square plus 3x plus 1 is divided by 5 plus 2x. Here the dividend polynomial is Px equal to 3x cube plus 3x square plus 3x plus 1, and the divisor polynomial is qx equal to 5 plus 2x, and let c be the 0 of the polynomial qx, then qc equal to 0. Qc equal to 0 means 5 plus 2c equal to 0, that means c equal to minus 5 by 2, then the remainder is what? Pc. Pc means p of minus 5 by 2, that means minus 5 by 2 whole cube plus 3 into minus 5 by 2 whole square plus 3 into minus 5 by 2 plus 1. We calculate the expression and the answer is minus 27 by 2. That concludes today's class. Thank you. Since you have watched this video till the end, then you must like this video, comment into it, and share this video into your WhatsApp group, and subscribe to our channel and press the bell icon to receive the notification on time. Thank you.